Assalamualaikum and hi guys, this is 7.3 part 2. 7.3 is regarding solubility, equilibria. Here are the learning outcomes. At the end of this lesson, students should be able to define and explain the common ion effect. So are you ready? Let's go. Common ion. What is meant by common ion? Common ion is an ion that is common to two or more components in a mixture of solution of ions. So we have a mixture here. Mixture between what? So let's see. Right, for example, when NaCl aqueous solution, a very soluble salt. So we have a salt here. We have NaCl, which is a soluble salt, is added to the saturated AgCl solution. Saturated means, as we all know, saturated is also known as slightly soluble solution. So the common ion present in this mixture of solution is, can you spot any ion that is common to each other? Yes. In this solution we have Cl minus. In this solution we also have Cl minus. So the common ion is Cl minus ions. You got it right. But then, what is the importance of this common ion? Going to look through what is the common ion effect. Common ion effect. Common ion effect is a shift of equilibrium caused by the addition or the presence of a compound having an ion in common with the dissolved substance. So common ion cause a shift in equilibrium. So how do it affect solubility? The presence of a common ion decreases solubility of slightly soluble ionic compound. Okay, let us see further explanation. So let's say we have a saturated solution, plumbum, chromate. So saturated, see the word saturated here? That's mean what? That means slightly soluble. Slightly soluble, it's not 100% soluble. Slightly soluble ionic compound. And then we add with a soluble salt. Soluble salt, for example, sodium chromate. Okay, since there are two solutions here, that means you must write two equations. So the first one, representing the saturated solution, as we know, as this is the slightly soluble ionic compound, so it is denoted as solid in equilibrium with its ions. We have plumbum 2 plus ion and chromate ion. And then since this is a soluble salt, that means it is 100% soluble. It will dissociate completely. Right? The state is aqueous. Okay, dissociate completely into its ion with the sodium ion and also chromate ion. So can you spot any common ion here? Yes, you can clearly see this, that the common ion is chromium. The common ion is the chromate ion. So now, when we add the soluble salt containing a common ion, that means the concentration of chromate ion increases. So how does this affect the solubility? So as explained by the Le principle, the equilibrium position will shift to the left. Why? Because if you can imagine a seesaw, right? First thing first, let's say this is the saturated solution. At first, this saturated solution is in this soluble salt is in equilibrium with its soluble ion. So the seesaw is balanced. Next, after you add the soluble salt containing the common ion, right, the concentration of the common ion increases. So what happened to your seesaw? It will be heavier on the left side. Since the concentration of the ion increases, so we need to decrease it back in order to gain equilibrium back. Okay, so in order to attain equilibrium, we need to decrease. So how do we decrease the concentration? Right? How do we decrease the concentration? Some of the chromate ion combine with Pb2 plus to form solid PeClO4. So that's mean we want to decrease back So the equilibrium portion will shift to the left. So now we reattain our equilibrium position like that. Right, so equilibrium shift to the left. That means we are going to use, in order to decrease this one, we need to use this chromic ion combined with Pb2 plus ion. That means produces more plumbum chromate solid. Therefore, concentration of chromic ion and plumbum 2 plus decreases, solubility decreases. Why? Because we are forming more solute. For example, for a clearer picture, we have a picturized explanation here. So let's say at first we have a slightly soluble ionic compound, which is this plumbum chromate. So initially this is the solid part, and then this is the slightly soluble part. It dissociates completely into its ion, right? And then after that, for the picture B, we add chromate, some more chromate solution, soluble salt containing chromate such as sodium chromate. So now what happened? We can see that we need to decrease the concentration. When we need to decrease the concentration, that means some of the chromate ion is going to combine with this plumbum ion, forming more plumbum chromate solid solute. Therefore, you can see here that more plumbum chromate form, making it is less soluble, right? So the same result, you can see the same result when you add soluble salt containing plumbum 2 plus ions, such as the plumbum nitrate, because this slightly soluble ionic compound consists of two types of ion, chromate and also plumbum. So whenever you are adding any soluble salt containing any of these two ions, you can see that the solubility will decrease. Later on, when you do calculation during your tutorial session, you can clearly see that in pure water, the concentration of the slightly soluble will be higher compared to when you have common ion. Right? So thank you for watching. Bye.